Hi, welcome to my channel, where I share my knowledge on programming the DJI Tello drones with Python. Today, we're going to start in on a new series where we program a custom heads-up display for these drones. And in this video, what we're going to be programming is a custom battery level indicator that updates dynamically to give us real-time insights into our drone's battery level during flight. Oh, and we'll be demoing this, and in doing so, you'll find that we experience more crashes. Now, if this sounds interesting to you, please join me on this journey. And without further ado, let's get started. Okay, so as usual, I like to start on GitHub. All the code's here that I'm going to be covering in this video. So if you'd like to skip through things, go pull the repository and try it yourself, download it and try it, please feel free to do so. The link will be in the description. Now, if you'd like to stick around, let's do a quick overview of what's in this repository, and then we'll move on to understand the methodology we worked through before actually writing any code. And lastly, we'll go into the code, understand the logic and how it was applied, then we'll demonstrate. So here we have Tello Drone Heads-Up Display Guidance System, HUD HGS, acronym. In this repository, we have an MIT license, open source and free, basic README, and then we have 3 code modules, Python modules. We have one called app py, indicators py, and then Xbox One controller py. Now Xbox One controller, that comes from a previous repository and the last video that I released on my channel. If you'd like to understand the specifics of this and how it works with the GUI module in that one, please check out that video. I'll also include the link in the description. Now, if you want to understand what we're doing here, well, let's continue on. So, we use our Xbox One controller PY to go ahead and control our drone. Because really, without a way to control the drone, what's the use of a battery indicator? I mean, we could fly it through the air and play, but it's just gonna overheat if that's not actually running anyway. So, let's go ahead and we have app py, which uses the Xbox One controller. It is actually taken from that GUI module from the previous repository, and all we do here is we add a few things so that it uses this indicators py module, which contains an indicators class, which we will code all of our indicator functionalities throughout this video series. And in this video, we're starting with the battery level indicator. So to code our battery level indicator, we had to kind of think things through. So I went ahead and I created a short clip here to share with you on how I thought this through and came up with a solution. So let's watch that and then we'll go into the code. All right, before we even consider sitting down at our computer and starting to code, let's understand the problem. So we want to visualize our Tello drone's battery level on our screen so that we can get some real-time insights as to where it is. Now, we're familiar with reading this battery level from the Tello drone in a previous video where we read flight data using the Tello drone's read commands from its SDK. So when we did that, we put a label, and then we printed that battery level right there. And then we added a little percent sign there. Now, I don't know if you can see that. Yes, you can. Okay, good. So that was nice because we were able to understand it. It updated in real time. All that was great. It's not very cool though. At least I don't think so. So let's think of how we can make this better. Well, when I think of a battery level indicator, I think of ones on a camera or your phone. I think of it having an actual battery. So let's start there. We'll draw our battery. We'll do a little positive terminal. So there's our battery. So that's what I want to draw on the screen. And I want this somehow to tell me what our percentage is on our current battery in use. So let's think of this a little more. The battery can be within 0 and 100%. That's good, we can use that. So let's go ahead and take the battery and divide it into 10 fractions. So we can divide it into 10 fractions. That's good. Now what are we going to do? Well, we're going to represent each 10th of the battery level with a bar. So we'll have 10 of these bars and we're going to put them in our battery to fill it up if it's full. So that's good, right? That's pretty cool already. So if we did this and we updated our battery level and we drew bars accordingly, we'd have the bars go down. Okay, let's go ahead and we're also gonna just say, we'll put the percentage next to the battery just for some visualization of the number itself. Cool, so what's next? Let me erase, we'll get back to it. All right, we're back. So went ahead and I turned my board around and I redrew our battery. So we know that we're gonna wanna draw this on our display, which will be our video stream because we're programming a heads-up display guidance system. Now, we'll print this using some OpenCV shapes, but we don't need to go into the details. We're still trying to decide how to make this cooler. We have made it a little cooler, but instead of using a label and printing percentage, we're gonna go ahead and fill this with bars. 10 of them to be exact. 4, 5, 6, 7, 8, 9, 10. 10 bars for 100% battery. Now, I want to color the bars according to what the current percentage is. This way, we have that kind of similarity between what we see on our phone batteries and whatnot. So let's go ahead and we'll take this first 4%. So this will be between, let's see, 70% battery and 100% battery. And it's gonna be 4 bars. Sorry about my writing. Now, so we have 4 bars that will be representative of our 70% battery life to 100% battery life. Let's go ahead and we'll let those be green. We'll just put a G there. All right, great, that's good. So then what happens if we drop below 70%? Let's color the bars yellow, yeah? So let's go ahead and designate between 40 and 60%. So that's these 3 bars. So we'll do 40%, 60%, 3 bars. And that will be yellow. Nice. Now, what do we do left with the last 4? Or is it 3? Well, it's the last 3. So these last 3 then here, we'll just go ahead and have those be from 0 to 30%, 3 bars, red. And that makes for 3 plus 3, 6 plus 4, 10. 10 bars, we have them each colored. Now I'm gonna step away again and I'm gonna draw this before we begin programming it. All right, so here is what our full battery indicator will look like. We'll go ahead, we'll have our battery shape, and within it will contain 10 bars, with each bar representing a fraction of the battery's percentage as a 10th. Now, between would be 70 and 100%, we'll have green bars. Then between 40 and 60%, yellow bars. And lastly, 0 and 30% red bars. And then we'll go ahead and we'll put the actual read value here, followed by a little percent sign. Nice. So let's say, start going down, the bars start going away. Our battery level's decreasing. Uh-oh, we reached under 70% battery life. That's how it's gonna look, guarantee it. So now we understand what we're gonna do, how we're gonna represent our battery level in a much more visually appealing way. We're gonna sit down and program it. Now, we also need a way to control the drone. So for controls, we're gonna go from our last video, we're gonna use our Xbox controller GUI. And we're gonna take that as a template, and then we're gonna build a new class, an indicators class. Using this class, we're gonna add all of our indicators throughout this video series. And starting with our battery indicator, we're gonna program the logic we just designed here, and then we'll demo it and see the exact same results. Our battery level decreases with colored bars and whatnot. So let's go into the program and see how we actually coded all this stuff. All right. So hopefully that video made it clear what we're doing, and now we can take that logic, that pseudocode if you will, even though it wasn't written like that, but spoken pseudocode, and we're gonna apply it into an actual Python module. So let's go ahead and take a look at our indicators class to start, because this is where all that logic takes place. While it's in our brain, let's go ahead and see how it's applied. So in this module, we import OpenCV, time, threading. We'll see why we use those here. It's obvious that OpenCV is for our drawing though. Then following our imports, we have our indicators class. So this class, we're going to initialize with the drone object, which is our Tello module, our Tello class, Tello object. And we're also going to initialize it with a width and a height. This is the width and height of our frames received from the Tello drone. We initialize them as part of the class because we need to use these to calculate the different positions for our indicators such that we can draw them on the screens properly. So with the width and height as a class variable, we're able to reference it throughout the methods of the class far more easily than if we were passing in width and height all over the place in our application module. So we have those taken in, and then we go ahead and initialize a variable first to start and stop our indicator updates. This is going to control our threading, so whether or not we want to update the percentage on our screen or not through a separate thread. So we're going to set it to false here because we're not going to start the thread right away until we instantiate our indicators object and call its methods. So after that, we go ahead and initialize the width, height, and the drone to these ones that we initialize the indicator class with. After that, we're going to go ahead and initialize the battery level. We do this by calling our Tello drone's get battery method. Now, if we can go ahead, give me a second and I'll pull up the library so we can see here. Alright, so here's the Tello module. Let's go ahead and Control F and type down get battery. Okay, so there is our get battery method we're calling. So that gets the state field for battery, and it returns our battery level as an integer between 0 and 100. Okay, so we got to look at that, understand where it's coming from. So when we instantiate our indicators, we instantiate it with the Tello class as a part of it. And then we initialize a battery argument or a battery attribute of the class, and we set that equal to the drone and its get battery method. Nice. Lastly, we're going to go ahead and start a thread. We'll go ahead and call threading.thread, where we create a thread and we set its target equal to a lambda, which calls this method below, update indicators. Doesn't take anything here. We'll look at that next. Before we do, let's mention that we're going to go ahead and start this thread when the class is instantiated. So that's how it's initialized. When we create our object, it has all those nice things going on. And the thread started right away. So let's look at this self.updates equal to false. Like I said, it's got to be set to true for us to be updating through that thread. Well, we set to true in our update indicators method. We're going to go ahead inside this method, we're going to start by setting it to true. This might not make sense right away, but we're going to go ahead and change it back to false in our app module, where we do a cleanup method, and we'll go ahead and set it to false there. But we'll see that in a minute. So we want to set this true, and then while it is true, all self.update equals true, we're going to go ahead and print that it's true and that we're updating the indicators. This was here for debugging. And then we're going to assign the battery of the class equal to drone's get battery method. So it's kind of like what we initialized it with, but by calling that method again, we're going to go ahead and update the value to the actual current reading from the drone. So after doing this, we're going to go ahead and sleep for 1 millisecond or 100th of a millisecond, whatever it is. Now, that's what our sleep value is because we have no thread manager. I'll have a little bit on this at the end of the code walkthrough. So just know now that we don't need a thread manager because it'd be a lot more complex. And instead, we're going to use well thought out time delays in between our different threading updates. Okay, so let's move on. And we're going to go onto the method in which we kind of discussed the logic for in that previous video clip. So this method, draw battery indicator. We go ahead and we take in a frame, we don't return anything. Now, we could take this frame in and call its width and height if we wanted to, but that would lead to more lines of code. We'd have to call frame.shape every time and then unpack the width and height from it. Instead, we assigned it as a part of our class so that we can go ahead and reference it without unpacking it from the shape. So in this method, we start by drawing two rectangles. Now, if you remember from our logic, we want to draw the battery. So we draw a big rectangle and then a little one for its positive terminal to make it look pretty. Now, let me go ahead and note in this right here. So we're going to draw the base battery shape, and then we're going to check the battery level and draw the appropriate number of colored bars in the battery shape. Gosh, it keeps popping up stuff. So we're going to draw the appropriate number of bars to indicate that representative power level. Here's my notes. So start and positions for drawing the battery are hard-coded as a calculation taken with the frame's width and height to position the drawn indicator in the upper left corner of the displayed video stream. So the width and height were used for this positioning. I decided I want that battery indicator in the upper left-hand corner of my video stream window. So as we go through this, keep that in mind. Next, the battery's form is drawn in the color white. So that way we can have it differentiate from whatever's in the background of the video, but also have stark contrast between our battery bar colors. So it's white and has a thickness of -1. That entails that we fill in that rectangle with the white. So it's a solid white filled rectangle. That'll again aid in our contrast between the bars. After this, we have a note on the battery level bars drawn as lines within the battery's form. We discussed this. Now, these bars are positioned within this form such that they are separated by 5 pixels between each bar in the form along its x-axis. So, lastly, well, I think I had a little note then along the y-axis. So these bars then are going to be, really give me a second. They will be 20 pixels, I believe. Oh darn. Ignore that for now. Touch your hope. So we note all the bars are drawn with the thickness value too. So I'm sorry about that confusion in my own discussion. So let's go ahead and just continue with the code lines, and then we'll figure out that y-axis. What I was trying to indicate is the length in which we draw the bars with. We'll see how we do that in a minute. So again, digressing, a bunch of jumbles. So we draw our base rectangle, which is the big rectangle of the battery, and then our little rectangle for the terminal. And then we're gonna do our if statements to check where the battery level's at. So if you remember, if that battery level was greater than 70%, then that means the bars are gonna be green. So check if it's greater than or equal to 70, and we're gonna go ahead and define the color as equal to the RGB equivalent of green. Now, next we're gonna check how many bars we need to draw based off of the battery's current reading. So we're gonna first check if the battery is equal to 100%. If it is, then we wanna draw 10 bars, 1 for each 10th of that battery percentage. Now, here is the note on how long the bars are. Well, they're drawn using the CV2.line method, and they're drawn starting at the top of the frame downwards in the y direction. And they're drawn to be 20 pixels long in the y direction, with 5 pixels separating each bar. So when you're looking at these positioning, we separate each by 5, and if you kind of do a little calculation, 50 minus 30 is 20. Nice. So within all of this if statement, if it's equal to 100, we're gonna draw 10 of those bars. We're gonna draw them to be green with this 5 positioning. So next we're gonna check if the battery is less than 100, but greater than or equal to 90. So if it is, we're gonna draw 9 lines. Now we can kind of see what we're doing here. This is kind of repetitive, so I'm not gonna go through every single line of code. And not to mention this too, we could probably clean this up and use a loop really. And maybe we will one day, but not today. So if it's not 90, well, then it's either equal to 80 or it's less than 90. Draw 8 lines, but they're green still. Then lastly, if it's not greater than or equal to 80, well, then we'll go up to our previous check. That means it's greater than or equal to 70, but less than 80. If that's the case, we draw 7 lines to represent somewhere around that 70% level. All right, our 4 green bars for our 70 to 100%. After this, we kind of do the same exact thing, except this time we're going to check if it's between 40 and 70, and if it is, we're going to set the color to yellow, or the RGB equivalent of yellow. Then we'll check if it's greater than or equal to 60. If it is, we'll draw 6 lines. If it's between 50 but less than 60, or if it's equal to 50 or greater than 50 but less than 60, 5 lines. And then if it's between 40 and 50%, draw 4 lines in yellow. All right, there's those 3 yellow lines. And again, the same thing. So if it's not any of those, if it's not between 40 and 70, and it's not greater than or equal to 70, then that means we're in our red area. That means that we're gonna have to set that color to red. We're gonna check if it's greater than or equal to 30, we'll draw 3 lines. If it's between 20 and 30, 2 lines. And lastly, between 10%, 20%, we're gonna draw 1 red line. That's great. That's exactly what we wanted to do. And we just looked at the code that does it. Now lastly, like I said, I wanna go ahead and put that actual battery percentage next to the indicator just to make it pretty. So we're gonna go ahead and put the text here, and we're gonna use an F string to write the battery level, followed by a percentage sign. And this positioning, again, is all hard-coded values, so you'll have to play with it. But if you're using the same output screen dimensions and all that as I am in this, you should be fine. Great. So that is our indicators module and our indicators class with our current indicator functional, which is our draw battery indicator. Now, this update indicators method will be used in our future videos to call other methods for drawing indicators, so that we use a single thread to update all of those different values and draw them to our screen. Great. All right, so let's move on. Go back up past the site packages we're looking for. Let's go to the application module. So I'm not going to spend a lot of time here because previous videos, GUI module with the Xbox control, pretty much identical. Change the name to app, because why not? And then we go ahead, we create a akin to a root window, set a title and a minimum size for it to be. Then we go ahead and find our capture label to hold our video stream, and we connect to the drone and start receiving video from it. Then we also got to set the drone's flight state to false for that takeoff land functionality. Alright, that's all previous stuff you should be familiar with. Next, we have something new. There's that width and height. We had to define what we want that width and height to be for our final video stream output, so that when we initialize our indicator, we can pass that to it. Now, in other videos, we went ahead and defined this in our video stream method. Instead, we're gonna take it and move it up here. Nice. So next, we're gonna have some other familiar things, all of these. So we're gonna initialize the state of the image for the video stream to none, initialize a variable to get the current frame by calling the Tello object's getFrameRead method. We're gonna define an RC controls variable and set equal to a list with 0 for the 4 RC control channels. This can be for updating our drone movements based off of our Xbox controller joystick values. Then we initialize our Xbox One controller object, and then one more new addition in our initialization. We initialize our indicators object as a part of the application class. We set it equal to our indicators, passing the drone object, the width, and the height. Okay. So, some additions to our initialization, but nothing removed and nothing too complicated. So let's move past. Takeoff and land method stays the same. This update joystick method, that stays the same. Again, previous video if you'd like me to go through it. Now, after this we have our run application method. Believe it or not, it stays the same, because what we're going to be doing updates on is not any of the control logic, but the video stream logic, which we kind of have this similar application loop. Not similar because it's a different loop, but our video stream, which we call in our run app method, which is under the akin terming loop. So our video stream method, that's where we read our frames and update them. Well, when we're doing that, we also want to draw that updated battery indicator. So we do that by calling self.indicators, and we call that draw battery indicator method that we were just looking at by passing in the current frame. What that'll do is then return the frame with that battery level drawn on it. Great. So that's pretty much it. But if you remember, we had that self.update of our indicators class. Now we're going to use that in this cleanup method here so that we can stop that thread from updating our battery level. We do that by calling self.indicators.update equals to false before we end our drone object, quit our root window, etc. That's it. So, like I mentioned, we'll take one quick look here because there's one point I want to note, and really this is all has to relate to threading. You might be concerned that with all these different threads and delays and whatnot, that something might cause for a race condition to occur or other related concurrency issues. So let's look here. We use a thread here, and then we use a thread in the indicators class, and then we also use a thread No, we don't actually. Well, we do. So we use a thread in our takeoff land command. Now, the difference between the threads and those other two modules and this one is that this thread is going to kind of perform based off of static operations. So you get one input, it does the command through a thread, but that thread doesn't continue to run. It sends the command once and it sleeps. So that's not really a concern. But there are also all of these different updates to our root window within our joystick update method and our video stream method. Now, we hard-coded those delays perfectly, but just to ease your concerns, I have a little bit of a video prepared to kind of address this a little bit more specifically. So let's watch that, and then we're gonna go ahead and take this and demonstrate our battery level indicator by flying the drone around and letting the battery level get lower as we do. So let's watch the video on why we don't have to worry about threading, and then we'll demo, and we'll call it a day. At some point in this video, you might have questioned if our use of threading will succeed with no proper thread manager in place. To ease your concerns here, I would like to justify why this is not an issue by explaining the decisions I made when engineering and employing threading for our needed tasks. The decision not to implement a thread manager in this program can be justified by the careful design and management of thread execution through hard-coded delays and the inherent characteristics of the tasks being performed. To better understand this, let's discuss the key aspects here. 1. Independent nature of threads. Each thread performs a well-defined, independent task that does not require complex coordination or synchronization with other threads, thereby reducing the complexity and potential for concurrency-related issues. 2. Effective use of daemon threads. By using daemon threads for background tasks like input monitoring, the program ensures these threads do not prevent the application from exiting. Daemon threads are terminated automatically when the main program exits, simplifying thread lifecycle management. 3. Experimental optimization. The use of hard-coded delays, determined experimentally, allows for fine-tuned control over thread execution timing and event handling. This approach can be effective in scenarios where the timing requirements are well understood and relatively static, reducing the need for a dynamic thread management strategy. 4. Simplicity and performance. Avoiding a complex thread manager can lead to simpler code that is easier to understand and maintain. It also avoids the overhead associated with more sophisticated concurrency management techniques, which may not be necessary given the specific requirements and behavior of the drone controlled and input handling tasks. In summary, the program's design leverages the simplicity and efficiency of threading with hard-coded delays to meet its concurrency needs without the complexity of a thread manager. This approach is deemed sufficient due to the independent nature of the tasks, the successful empirical determination of optimal delay times for critical actions, and the use of daemon threads to ensure graceful application behavior. So here we are. It's time to demonstrate this battery indicator we have for our Tello drone. So I have the Tello Talent, use your Tello EDU, and imagine the original Tello drone. I have not calibrated this since our last crash in which I had a propeller break. So if you see any unexpected behavior, know that's why. And hopefully I can correct it without crashing again. So what I'm gonna do is I'm just gonna go ahead and fly it around and let the battery die. So play a little tune while it goes on and enjoy. Okay, so I forgot to mention, I've charged the battery all the way up. So it should be at 100%, if not just below. But this will be also a test of how well our battery lasts, what its lifetime is. So I wanted to note that before we take off. I did charge the battery fully. I confirmed that because the blue light was solid when it was plugged in, and that was just a second ago. So we'll see for sure what's going on here. Okay, so connecting to the Tello drone, I'm gonna take it off and begin flying. Like I said, battery's fully charged, so we're really gonna get a test of how our indicator does and how well that Tello's flight battery does. So let's go ahead and hit run on our app module. This will run the Dunder main in this module, creating our GUI and drone and whatnot. And there we go. So my battery is reading 67%. I swear it was charged before this, but you know how it is. All right, let's do it. I can hold my mic. We see the battery is going down 72 to 71 to 70. Now maybe we can just do some spins. Ah, we went to yellow. Nice. So we dropped below 70 and our battery indicator went to yellow, just like we programmed it to. That's great. We're gonna keep doing this. We're gonna run it down until it turns red next. Okay, so I'm not very good at flying the drone. Now, this gives me a good opportunity to raise a point. With our Xbox controller, what happens if we've taken off and a crash occurs, but we didn't actually press the land button? Well, in our program, the status is still going to be registered as flying because of our isFlying attribute that we use to send our takeoff and land commands. So, with this case, we don't really have anything in place to help us just press the button again. But what we do have is we have that drone.reboot in our cleanup method. So what we can do now is terminate the program. It'll call that drone.reboot and it'll allow us to reestablish a new connection with the drone without having to power it off and back on again. So we see our batteries at 56. Let's go ahead, exit out here. Now we got an unsuccessful land command because it did probably experience that crash. Okay, no, that land command was sent after I closed out of the window. So it still tries to land. We're gonna have to go ahead and program an extra little thing in there. So in our cleanup, maybe we should check first, is the drone flying? If it's flying, let's send the land command, or at least send it and set its status to not flying. We'll see. That'll be us reapproaching this program, making it better together. So through experimentation, we make better programs and more effective programs. So now our program has ended. We should be able to rerun it without having to power our drone off and on again. So I'm gonna hit run. Stream on okay, connect command was okay. That's the point of that reboot command. So it works for what we need it to do. Now let's try to fly this down until it's red again. So it definitely needs calibrated. Yeah. Alright. On it with the crashes. On it. So I keep crashing probably because I need to calibrate the drone. I'll tell you what, this still is a good test of our battery indicator because as we can see on our screen, let's see, yeah, you can see it there. Well, it's gonna be that like repeating screen tunnel, but we're at 56% and it's yellow. So we're gonna go ahead and just keep doing this, work that battery indicator down until it's red. That way we have proof that it works like that. So let's go ahead and close our window again. And that will send that reboot command. Now the land command might be unsuccessful, whatever. I don't think that it matters. That reboot command is in place as it is for a reason. And you know, I've been programming these drones for a little while now, so I probably have tried doing the experimentation with that unsuccessful land and whatnot. And reboot might be the best approach, but if you guys have tried anything else, have any other suggestions, let me know. let's go ahead and run it again. Time number 3. So I'm not gonna do much crazy flying this time. I'm just gonna spin in circles because drone is not very well calibrated. So we'll go ahead and put drone in here, Tello right there. Let's take off again. We're gonna take it right where we can see and we're just gonna spin. Oh, and it's going down because I have it going down slightly. So there's a nice little thing you can do if you wanna. Yeah. You can go the other way. Oh, look at that. That's fancy. Woo! Woo! Whoa! Alright, we're gonna bring it back. So we're now at 54%. That battery really drops quickly and then it lasts a while. Yeah, we are not calibrated well. Those right or backward movements are not going that great. That's kind of cool. So I'm just having fun here, as you can tell. I'm just running the battery down. So you gotta switch it over. Now, without crashing, I think we have a fuzz popping over. That might be part of our reason. Alright, so we are still at 54%. I wonder if that's actually updating. Maybe we could take a look here. Well, it is updating the battery. Let's just keep it running. Ah, okay, 53%. Good deal. So we just need to, maybe if we do that, we're gonna maximum it. So we're gonna down and up. Real hard thrusts with the drone. That'll really cause the motor to use a lot more power because it's experiencing that downward force. It's having to account for it by an extra upward force. It's more efficient, right? So we're just gonna get down to 30 and then we'll call it a day. We're getting there. I don't want to make anybody dizzy, so I'm sorry if that happens. But there's nothing I can do about it, so I guess just quit watching the video. Almost there. We're almost below 40. We should do our 3 bars. 40% now. Here's the moment of truth. And it drops 39. We got red bars. Alright, let's go ahead and send our land command. Yeah. Alright, let's just go ahead and close this. So, we had some crashes again. Like I said, I'm not the best drone pilot, but I did okay. So, we saw the use of our reboot command in action. It helps for experimentation and testing, and that's what we're all about here. So, it works great. We went from green bars once it hit 70, and then below, we went to yellow bars, and then once it hit below 40, we had red bars. And the battery did pretty good. Now, we could go ahead and just say that it doesn't work to do the testing the batteries in this video because I crashed too many times. Drone's not calibrated, and really it's not a good measure of its accuracy given all that. So maybe another video we'll do a real battery test, and we could even just use this, maybe go outside so I don't crash. Yeah. It's a good idea. So, what do you think? You like the battery indicator? Find it helpful? I hope so. I mainly like it. It's visually cool. And I think that it's gonna help us with future videos here when we're gonna wanna maybe visualize some of the data as we're working with it. Why would we do this? Well, PID control. So battery's not really gonna play into this, but what we're gonna have next is pitch, roll, yaw indicators. And when we're programming a drone to track an object, face, whatever it may be, we need to have a PID controller, which is a mathematical kind of acronym, proportion integral derivative. It's all about accounting for error. So we'll see that in future videos, but it'll help to visualize this all with our heads-up display. I think it's important that we go ahead and do this all first. So now you know what's upcoming, some really cool stuff. I've got some number of tracking programs. So if you want some tracking programs, we're gonna keep doing this, keep putting videos out, and hopefully get some from it. Now, tell me what you guys think. Any suggestions or thoughts in the comments. I love to hear from you all. And I appreciate when you like, comment, and subscribe, of course, is a given. So, as always, I appreciate your support. Until next time, have a great day.